This is our second example with working with coefficients of friction to solve problems. And we're going to have the same pineapple, but this time the baby is going to come along and pull horizontally with 2.5 newtons. So less force than last time. Same mass of the pineapple, same coefficients of friction. What is the force of friction on the pineapple and its acceleration? Well, from last time, we found that the maximum force of static friction was 3.4 newtons and the kinetic friction was 2.6 newtons, and those depend on the normal force. So if we haven't changed the normal force, which hasn't changed because the mass of the pineapple has not changed, and we still have only horizontal forces, these forces will be the same. So I'm going to go ahead and transfer those. So the maximum force of static friction was 3.4 newtons. And the force of kinetic friction was 2.6 newtons. So in this problem, if I draw a free body diagram of the pineapple, we have the baby pulling with 2.5 newtons. And we have some force of friction. And we have the normal force and the force of gravity. Now the pineapple starts at rest. So in order for it to move, the force of the baby would have to be greater than the maximum force of static friction. So let's look, what's the maximum force of static friction? That's 3.4 newtons. So the baby is not pulling harder than what friction can oppose with. So that means that the pineapple is not going to move. Which means that the pineapple is at rest. So if the pineapple is at rest, that means that there must be balanced forces on the pineapple. So if the forces are balanced, that means the force of the baby is 2.5 newtons, and the force of friction must also be 2.5 newtons. And because it's at rest, this is static friction, which is balancing the force of the baby trying to move the pineapple. So the force of static friction can increase all the way up until 3.4 newtons. If the baby pulls with more than 3.4 newtons, then the pineapple will move. So the force of friction on the pineapple, now we can answer that. The force of friction is static, and it's 2.5 newtons. And then the acceleration of the pineapple is 0, because it's at rest. And a little bonus part B to this, just to sneak in one more idea, is to ask the question, what force would the baby have to pull with to make the pineapple move at constant velocity? So let's suppose that the baby has gotten the pineapple moving. So the baby's pulled with more than 3.4 newtons, got the pineapple moving, and now wants to move it at a constant velocity. Well, constant velocity means balanced forces, but if it's moving, that means we have kinetic friction. So the force of kinetic friction is 2.6 newtons. So the baby would have to balance that force of kinetic friction So the baby would have to pull with an equal force to that, which would be 2.6 newtons.